So looking at an overview of this unit, we're looking at the review of standard position, and we're going to focus on doing this in radians. Okay, you're expected to do things in radians now. So most problems you're going to have to, you should really switch your mode to radians, and then there are maybe the odd time you may need to use degrees, and I would just use a conversion factor to degrees. So here's a problem here. We're being given the cosine ratio. We don't know the quadrant, so we should always consider there's always two possibilities. If we don't know the quadrant, we have to give both answers. So cosine theta is negative 1/2. That's a special angle, so we should recognize that. So I'm going to draw it in quadrant 1, -1 and 2, and we can also draw this in quadrant 3. So it's quadrant 2 and quadrant 3. So these are our angles. There's theta, okay, and there's another theta in quadrant 3 here. Okay, and I'll do that triangle in blue. Okay, so we need to find the exact values of theta. So looking at that picture, okay, since it's exact values, we need to recognize that theta 1 is to do with the 30-60 triangle. So we need our references, pi over 2. That's going to be 2/3 of the way from 0 to pi. So that is 2 pi over 3. The other angle is symmetrical. And we can see that symmetrically it's the same angle backwards from 2 pi. And that's where we get the formula for cosine. It's actually 2 pi minus theta 1. Okay, which was pi over 2 pi over 3. So theta 2 works out to be, what's that going to be? It's going to be 4 pi over 3. So that angle measured in this direction, the positive direction, is 4 pi over 3. Technically this negative, you could use negative 2 pi over 3. That's actually the right position. But the question does ask to have it between 0 and 2 pi. So we need to find the coterminal angle going around the other direction. So solving this one for exact values, well, cosecant, well, it's much easier for most people to convert a cosecant into a sine. So that's the first thing I'm going to do. I'm going to convert that to a sine. And that ratio is fairly familiar. That is a 45-degree triangle. And again, we need to figure out where we're going to draw this. Okay, sine is y, cos is x. So when we draw this, we know it's going to go down. It's going to go down in these two quadrants. Okay, so there's theta 1 and theta 2. Okay, so if I want to find this angle, I need to recognize that that's a 45-degree angle, or pi over 4, and I'm going to go past pi. So I'm going to call that theta 1. And that's going to be 1/4 pi past 1. So it's going to be 5 pi over 4. Now the symmetry for sine is across this line. And it's the same as if I go backwards from pi this way. So the formula looks like this. Okay, this one is a little bit hard to see because of the overlapping nature of it. But it's pi minus 5 pi over 4. Okay, and we're going to end up with negative pi over 4. The problem is negative pi over 4, it is the right spot, okay, but it's in the wrong direction because we need that. So although this is a formula for theta 2, really, if we can see the diagram, okay, if we can see this and understand the symmetry, we know going around this way, I'm going to be 1/4 pi short of 2 pi. So it's going to be 7 pi over 4. Okay, so this is the one that we're looking for, although this technically is correct, but it does not match our domain that we were given here.